This is part 2 of Unit 9, the atmosphere. Today you are going to start by using that big ideas sheet that you got right at the beginning of this unit. And this is a sheet that we are going to be using over both units 9 and 10, which is why we don't have it stapled in the packet yet. We're going to add it. It'll be a page in our Unit 10 packet. We're going to use this to collect what I call the big ideas in weather as we come across them. And so when you do these, each of these boxes will hold one of these big ideas. And you need to make sure that you write every single word of each big idea. So whatever I have on the screen in front of you, please make sure you write them exactly with the same wording. But then what you're also going to do is add a quick little sketch or illustration to the box. And it does not have to be as elaborate as the one you see on the screen, although you can certainly use that for inspiration if you want. You also do not need to use color. Just a quick visual sketch to help illustrate the idea that you're writing down. Okay, so as we're going to get started here, please first of all make sure you have your first and last name on the blank on the sheet. And we are going to use this first box way up in the upper left-hand corner for our first big idea. All right. So the first big idea is an overarching one, and that is that the sun is the source of all energy in our atmosphere. So make sure you write all the words and again do a little visual to help illustrate that. Once you're done with that, pause if you need another second. But once you're done with that, we're going to use these next two boxes now for the next two big ideas, which both are going to come from what we were doing as we looked at the layers of the atmosphere. So as you go up in the troposphere, the temperature goes down. And as you go up in the troposphere, air pressure decreases. When you're finished with your big idea sheet, you can just set that aside. We'll come back to that again later in the unit. And turn to your score sheet, please, and add assignment number 4, which is for your notes on pages 4 and 5. Once you're done writing on your score sheet, please turn to page 5 and double check that you've got all the notes filled in. And today for your highlighting, we're going to start something a little different in this unit, and that is that you are going to decide for yourself what you think is important to highlight on the page. So take a minute, go through, do highlighting that is helpful to you to point out key information, to be helpful when you come back and review your notes later to help highlight the important information. After that, move on to your 3 questions, and please use 3 different question starters. And finally, for your summary, you are going to choose your own type of summary to do. Just please write the name of the type of summary you choose, like if you do a 20-word gist or a Q&A or whatever, write it on the top line. If you need ideas or instructions, look on your Team Tsunami Toolkit on the summarizing page, and of course there's ideas and instructions there. So pause the video now and take time to finish up these 3 tasks. All right, before moving on, please double check that you have highlighted, that you have written 3 questions with 3 different question starters, and that you have written a summary for this page and written the name of the type of summary on the top line. When you're done, we've got one more thing to do on these pages. Please go over to page 4, and you've got one little space down in the bottom corner of page 4. So down in the bottom right-hand corner of the page, if you would please write this title, What Causes the Northern Lights? And then add 4 bullet points and space them out as best you can in the limited space that you have. And I have a short video I'd like you to watch that should help you answer the question, what causes the Northern Lights? So as you're watching, write down key things that contribute to us having the Northern Lights.
The Northern Lights are beautiful and odd, and they've understandably inspired tons of myths over the years. Like the Vikings thought they were a bridge to Asgard, where Thor and the other gods live. And another Norse legend says that they're the light reflected off the Valkyries' shields. And then people in Finland thought it was the Archangel Michael, John Travolta, fighting Beelzebub, the devil. The problem is, those are wrong, wrong, wrong. They're all wrong. It was actually Galileo Galilei, the famous early astronomer and recanter of science, who gave the Northern Lights their name, the Aurora Borealis, which in Latin means dawn of the north. But it wasn't until Norwegian scientist Christian Birkeland in 1896 figured it all out that we came to fully understand what causes the Northern Lights. See, in the center of the Earth, you will find hot, molten iron just roiling around under tremendous gravitational pressure. And this roiling effect of the molten iron creates magnetic fields that shoot out from the center of Earth through the crust and into the space around the planet. That forms what's called the magnetosphere, and it's a good thing we have it because we're constantly being bombarded by charged particles from the sun. The sun is so hot that it exists in a fourth state of matter. There's gas, liquid, solid, and then plasma. And in plasma, ions, which are positively charged atoms, and electrons just float freely around one another. And these particles have such a high energy charge that they can escape the massive gravitational field of the sun and barrel toward Earth at like something around 1,000,000 miles an hour, like a shotgun blast full of solar hate. That's called the solar wind. When these particles encounter our magnetosphere, most of them just kind of bounce harmlessly off. The Earth is saved. But some of them manage to get through at the places where the magnetosphere is weakest, at the North and South poles. You follow me? When the electrons that make it through our magnetosphere and into our atmosphere encounter oxygen and nitrogen, the electrons transfer energy to these atoms and excite them. And to calm back down, the oxygen and the nitrogen have to shoot off some of this energy, which they do in the form of tiny packets of light called photons. Beautiful, beautiful photons. Depending on where in the atmosphere the electrons interact with the oxygen or the nitrogen, different colors will be produced. Like for example, oxygen up to about 150 miles will produce a nice yellow-green color when electrons bombard it. Above that, it emits a nice red color. And then nitrogen, up to about 60 miles into the atmosphere, puts out a really beautiful blue. And all these colors can mix together, forming beautiful glowing pinks and purples and whites. It's like Miami Beach up there. So this interplay is most vibrant during solar storms, which depend somewhat on the solar cycle. And it's always going on. But the thing is, you can't see the Northern Lights during the day because they tend to be outshined by the sun.
All right. When you are done writing your 4 bullet points and make sure everything's good to go on pages 4 and 5, please stop the video and go up and get your stamp for pages 4 and 5. And this is the end of part 2.